Question number 6. This question is from Kinematics of Motion. An elevator is pulled vertically upwards by a cable. The acceleration and the elevator accelerates at 0.4 meter per second square for 5 seconds, then travels at a constant speed for 25 seconds. The elevator then deaccelerates at 0.2 meter per second square until it comes to rest. A part of this question is find the greatest speed of the elevator and hence draw a velocity time graph for the motion of the elevator. First we draw a sketch of this question. Velocity, we draw a velocity time graph for this. Velocity along y-axis and along x-axis we are taking time. An elevator is pulled vertically upward by a cable. The elevator accelerates at 0.4 meter per second for 5 seconds. So for this we draw a straight line from the origin. This line shows the acceleration. Accelerates for 5 seconds. Acceleration is 0.4 meter per second for 5 seconds. We will mention here 5 seconds. These are the important features of this graph. Speed is v here. Let speed is v here. Then travels at constant speed for 25 seconds. This horizontal line shows constant speed for 25 seconds. So here second 5 seconds uh, travels at constant speed for 25 seconds. So this means that time on the axis here is 30 because this time is 25 seconds. The elevator then deaccelerates at 0.2 meter per second until it comes to rest. Now we will make a straight line that shows the deacceleration. Deacceleration is 0.2 meter per second square until it comes to rest. The graph touches the y-axis shows that the elevator is at rest here and we will find here the time. Let it is t. Now find the greatest speed of the elevator hence draw a velocity time graph for the motion of the elevator. Greater speed is this. When it accelerates, greater speed is this. We have to find v. So we will take the gradient of this straight line, and that shows the acceleration. For gradient, we have these 2 points. So these points are 0, 0 and 5 V. So gradient is gives us acceleration. So acceleration will be V minus 0 gradient y2 minus y1 over x2 minus x1. So we get acceleration V over 5 is equal to, acceleration is given, that is 0.4. From here we get V is equal to 2 meter per second. Greatest speed is greatest speed is 2 meter per second. Now what is the value of this t? Since the deceleration is given, we will find the gradient of this line, that is equal to 0.2 meter per second. This is deceleration. We will take its sign negative because it is deceleration. So we will find the gradient of these 2 points and will equate to the deceleration. We can find the value of t. So for this t, we are taking these 2 points on this straight line that shows the deceleration 32. This is 30. This is 2. We have find v is equal to 2 meter per second. This point is 30 at t is 30 and v is 2, and this point is t 0. Now we will find the gradient of these 2 points and equate is equal to minus 0.2 meter per second scale because the acceleration is given. So 0 minus 2 over t minus 30 is equal to negative 0.2 because the acceleration. So we are taking here the negative sign. Simplifying it, we can find, so from here 0.2 into t minus 30 is equal to 2. T minus 30 is equal to 2 over 0.2. From here t is equal to 40. So this is t is equal to 40. Now we have mentioned all the important features of this graph. These are the important features. These readings shows the important features of this graph. Now clearly this diagram is a trapezium because two sides parallel, these two sides non-parallel. So in the next part we have to find the total distance traveled by the elevator. So we know that in speed time graph, area under the graph will give us the distance traveled. So we will find the area of this trapezium, that will give you the distance traveled. So area of trapezium, 1 over 2 sum of parallel sides. This is formula into uh, distance, perpendicular distance between these two parallel sides. So 1 over 2 sum of parallel sides. These are parallel sides. This is 40 and this is 25, and height is this, that is 2. So we are putting the values here. 1 over 2 into 40 plus 25 into 2. After simplifying, we get it 65 meters. Area under the graph will give us a distance. So distance is equal to 65 meters. Next part of this question is the mass of the elevator is 1200 kg and there is a crate of mass m kg resting on the floor of the elevator. Given that the tension in the cable when the elevator is deaccelerating is 12250 Newton. This is the value of the tension in the cable during the deacceleration. Find the value of m. So for this we again make a diagram. Let this is elevator. Cable, direction of tension in the cable, direction is also a force, direction upward, and this is a mass resting on the floor. This is the floor of the elevator. A mass of a crate of mass m kg. This is a crate. This is a crate of mass m kg. So total mass will be 1200 plus m. Mass of this crate is m kg and the mass of this crate is 1200 kg. So weight that acts vertically downward will be 1200 plus m into g, mg. Now we will use here tension is given in the question 12250 Newton. Now we use here a Newton. Second law of motion, F is equal to ma. So this is the net force. Net force in this question is T minus this weight of the elevator and the crate is equal to ma. Using Newton's second law of motion, 1 2 2 T minus weight is 1200 plus m into g is equal to ma. M is 1200 plus m into a is because it is deaccelerating, and deacceleration is given in the start of the question. Deacceleration is 0.2 meter per second square. So we will take its value negative because it is deacceleration negative 0.2. Now putting the values of tension and the value of G we get 12250 minus, uh, now we will multiply this G by these two terms, we get here 12,000 plus 10m. G into m, G is 10, acceleration due to gravity 10m is equal to, now this minus 0.2 will be multiplied by these two terms, we get minus 240 minus 0.2 m. Now simplifying it, 12250 minus 12,000 minus 10m is equal to minus 240 minus 0.2 m. Further simplifying, subtracting these two terms, 250 minus 10m is equal to minus 240 minus 0.2 m. We get 490 is equal to 10m minus 0.2 m. From here, 490 is equal to 9.8 m, and m is equal to 490 over 9.8. Finally, we get the value of m is 50 kg. This is the answer, 50 kg. This is the value of m, that is the mass of the crate that resting on the floor of the elevator. This is elevator, this is the crate. This is crate. The mass of the crate is 50 kg. Now next part of this question, part D, is find the greatest magnitude of the force exerted on the crate by the floor of the elevator and state its direction. So we make the diagram once again. Now this is a elevator. This is a mass of crate. This is a crate. Now by Newton third law of motion, reaction of the floor of the elevator uh, uh, will be R Newton acting vertically upward. Weight of this mass, this crate, will be vertically downward and reaction will be upward. This is a crate of mass m and reaction is R. Cable tension. Now, so m we have already found. M is m mass of the crate is 50 kg. Now again we are using here the Newton third law, Newton second law of motion. F is equal to ma. Net force will be T as R. Sorry, we are applying here uh, R minus mg. Weight is vertically downward. Weight of the crate will be acting vertically downward. Mg, that is 50g. So by using Newton's second law of motion, R minus mg is equal to ma, or we have to find mg 50g is equal to m is 50. But now we will decide here uh, if we are taking here acceleration or deceleration, because we have to find the greatest magnitude of the force exerted on the crate. Maximum greatest value of R we have to find. So we will take this A is the acceleration, not deceleration, because if we will take here the deceleration, then R cannot take the greatest magnitude. We will take here acceleration. Acceleration, we have acceleration is, it is given acceleration is 0.4 meter per second square. So we are taking here acceleration 0.4 meter per second square. So putting the value of this g, that is 10, we get r minus 500 is equal to 20. It is very clear that if we are taking here negative value, so we cannot get this value of our greatest, because negative, this value will be 500 minus 20, this is 480. But if we are taking this positive, then this term will be added here in the right hand side. We will get, so we can get the greatest value of r. So mm, simplifying it, r is equal to 500 plus 20. So finally, we get r is equal to 520 Newton. This is the reaction of the elevator on the reaction of the floor of the elevator on this crate. 520. This is the Newton. This is the value, greatest magnitude of the force exerted on the crate by the floor of the elevator, and state its direction clearly. Direction is upward. Direction is its direction is upward.